So now that you have an idea of basically how Java's compare and swap long operation works, let's see how this could be used to implement some of the actual interesting stuff, to my mind at least, which are the Java classes, AtomicLong and AtomicBoolean. So what is AtomicLong? AtomicLong is a nice Java wrapper around the compare and swap operation, and it's used to update a long value, hence AtomicLong, atomically. There should come no surprise that there's also an atomic integer class, which updates an int value atomically, and there's an AtomicBoolean class that updates a Boolean value atomically, and so on and so forth. Under the hood, as you might expect, AtomicLong uses the unsafe compare and swap long method that we just talked about. And here's how the class is actually laid out. It's really cool, and you'll see this pattern used repeatedly throughout the atomics, and it's a very interesting pattern to be aware of. So what it does is it defines a single field called value, which is given the volatile type qualifier. So you can see we have private volatile long value. And volatile here is very important because that means it's going to be atomically read and written to that memory location in main memory without getting stuck in a processor cache. Then the implementation uses Java's reflection mechanism. And this is really cool. Look what it's doing. It's going in and it's using the so-called static initializer portion of the class. So AtomicLong has a static initializer portion, which is going to be essentially called when the class is brought into the program, when the class is instantiated, not an object of the class, but the class itself. And what that does is it goes and sets a private static final long value called value offset. It sets that by finding the field offset from the beginning of an instance of the AtomicLong object, and it's going to give you the offset in bytes from the beginning of the field, or from the beginning of the object. So what it's doing there is it's saying unsafe object field offset, which is another unsafe method in the unsafe class. It says AtomicLong.class.getDeclaredField value. And that's going to give you back the offset in bytes from the beginning of any given AtomicLong object. And let's say, just for sake of argument, that the value is 4. So that says to the other parts of the program we're about to look at, you can find the start of the value field at an offset of 4 bytes from the beginning of the object. And I chose 4 because there's, well, maybe I should choose 8, but either 4 or 8, it's some value like that, because there's probably going to be some kind of virtual pointer or V pointer that points as the 0th location to the V table that would correspond to these classes if they use if they don't all use non-virtual methods. If they're all final methods, for example, there won't be a V pointer because there won't be any V table. Here's what the get and add long method looks like in unsafe. So you can see it's basically a little wrapper around compare and swap long. And what it's going to do is it's going to atomically update a value at an offset in the object. And again, if you go look at the source code for the unsafe class, you can see this code. If you go to the link at the bottom of the page, it takes you to the source code of the unsafe class. And here's what it does. It's going to use a do while loop that will invoke the compare and swap long method. And this is what's known as a lock-free call. It never blocks, it just spins. And if all goes well and there's low contention, it won't have to spin very much. It may just spin one time, in fact. Notice that we pass in the object, which in this case is going to be the AtomicLong, and we pass in the offset, which is that field offset we just talked about that was provided through reflection. And so that'll give us the field location from the start of the object. And in this case, V is going to be the value at offset bytes from the start of object O. And we're going to use a little helper method called getIntVolatile, which will atomically read the value at that offset from the start of the object. So we get the value of V. That was an atomic read. Delta is going to be added to this value atomically. And this is really, really cool. And the way this works, if you take a look at the code, it's using compare and swap long. And it's basically saying, if the current value at that offset is V, which is what we just received by getting the value, then go ahead and add delta to V. So what that's going to do is it's going to add whatever delta is. Delta could be 1, delta could be -1, delta could be 5, whatever delta is. It's going to attempt to update the value at that location to the value plus the delta if the value still has the value V. And so this is why it's atomic, because it only does that change when the value is what's expected. And so if the value is not what's expected, then it won't make the change. It'll just keep spinning. And here's how this gets used. There's a bunch of methods in AtomicLong, like get and increment, get and decrement. And as you can see, get and increment calls the get and add long method on this object, the AtomicLong, with the value offset with the value 1. And what that's basically saying is add 1 to the current value atomically. Likewise, get and decrement does the same thing. It calls get and add long, passing in this, passing in value offset, but it passes in -1. So what that's saying is subtract 1 from the current value of the AtomicLong atomically. So you can see this is how we're going to increment and decrement atomically. So you can think of these as kind of the atomic equivalents of plus plus and minus minus, if you're familiar with those concepts in C, C++, Java, C#, and so on. Now, there's also a method, and this is very important for you to understand, because this is what you're going to have to use for your programming assignments, the compare and set method, which is just a little wrapper around compare and swap, in this case, compare and swap long. So compare and set on AtomicLong is going to take an expected value and then updated value, and it's going to use compare and swap long, which is that unsafe method we looked at earlier, and it's going to go ahead and make that change. So it's going to go ahead and atomically swap the expected value with the updated value when they happen to match. And it'll be a one-shot thing. If it works, it's atomically updated. If it doesn't work, it'll return the existing value, and you'll know that you didn't get the swap that you wanted to have work. And you really have to understand how this method is going to be used to do assignment 1B. There's also another interesting method called get and update. And this is really cool. And this is a method that will atomically update a current value with the results of applying a given function and returning the previous value. So this is a really good example of the power of these atomic operations. So what this is going to do is it will get the current value by using the get method, which atomically returns the current value. And then it goes ahead and it calls the update function apply as long method on the previous value. So that takes the previous value and it returns a new value, or the next value. And then we're going to loop using compare and set until we can atomically replace the current value with the result of updating it. And so this is a way of, again, doing a more generalized update. And again, if it succeeds, we've atomically updated the contents of the AtomicLong by calling a function to take the existing value and then update it according to what we're trying to modify it to be. And when we're done, we return the previous value so you can see if we made any change. And this will keep looping until it is successful. And then there's also another method called update and get, which also uses compare and set. And the main difference is it returns the new value or the next value rather than returning the previous value. So it's kind of like the difference between ++I and I++. You can kind of think of those things in that way. So that was AtomicLong. Let's also briefly talk about AtomicBoolean. And as you'll see, it works very similarly to AtomicLong. The difference is, as you might expect, it's going to keep a Boolean value, true or false, as opposed to just an arbitrary value that could be whatever a long is. The setup is almost identical. It is identical, really. We've got a field that's going to be the value field, and we're going to have the value offset that's set using reflection. So that's exactly what we had done before. And this time, however, we use a volatile int as opposed to a volatile long. So we don't use volatile bool, and that really has to do with cache-related issues, but ignore those for now. Here's compare and set, how it's used for AtomicBoolean. Looks very similar to AtomicLong, except that we're dealing with Booleans in this case. So you can see that the parameters that are passed in are Booleans. And what they do is the Booleans will then be converted to either 1 or 0, depending on whether it's true or false, respectively. And then those values are what are passed into compare and swap int. But other than that, it's basically the same idea. So for your programming assignments, the undergrads are going to need to use AtomicBoolean, and the grad students are going to have to use atomic reference, which is basically the same thing as AtomicLong and AtomicBoolean, except you can work on arbitrary types that are parameterized using Java generics. You can also see here that the set method that's used on AtomicBoolean or on atomic reference or AtomicLong will take a look at what the parameter is and then atomically set the value to either 1 or 0. And why this is important is because the value is a volatile. So setting its contents to 1 or 0 will happen atomically because it's a volatile variable, as we defined earlier. Okay, so that's the overview of how AtomicLong and AtomicBoolean are implemented. In addition to just understanding how those classes work, because they're kind of cool, you also now will have enough information to start on assignment 1B, where you'll have to use AtomicBoolean and or atomic reference, I should say, or atomic reference, because grad students use atomic reference, undergrads use AtomicBoolean in order to implement a spin lock or different flavors of spin lock, depending on whether you're doing the class for the grad version or not.